Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're diving into the exciting world of CompletableFuture, the final section in our chapter on futures and callables. Are you ready to complete our future, Victor?
Absolutely, Sheila. I'm excited to wrap up this chapter with such a powerful tool in Java's concurrency toolkit.
Before we jump in, let's start with a quick quiz for our listeners. Here's the question. In asynchronous programming, what's the primary advantage of using a completable future over a regular future?
Ooh, that's a great question, Sheila. It really gets to the heart of why CompletableFuture was introduced. Listeners, think about the limitations you might have encountered with regular futures and how you'd want to improve upon them. We'll reveal the answer at the end of the episode, so stay tuned.
Now, let's set the stage for our listeners. We've already covered the future and callable interfaces in our previous episodes. Victor, could you quickly remind us what these are?
Certainly, a future represents the result of an asynchronous computation, while a callable is a task that returns a result. These are the building blocks for handling concurrent operations in Java, but they have some limitations, which is where CompletableFuture comes in.
Great, thanks. So, Victor, what exactly is a completable future and why was it introduced?
A completable future is a more advanced implementation of the future interface. It was introduced in Java 8 to address the limitations of regular futures. Think of it as a recipe for an asynchronous computation that can be combined, chained, and manipulated in various ways.
A recipe, you say? That's an interesting analogy. Could you elaborate on that?
Sure, imagine you're cooking a complex meal. With a regular future, it's like waiting for a dish to be ready before you can do anything else. But with CompletableFuture, you can prepare multiple dishes simultaneously, combine ingredients from different sources, and even change your recipe on the fly based on how things are progressing. It gives you much more flexibility and control over your asynchronous cooking process.
That's a helpful way to think about it. So, how do we create a completable future?
There are several ways to create a completable future. The simplest is to use the static factory methods like CompletableFuture.supplyAsync for operations that return a value, or CompletableFuture.runAsync for operations that don't return a value. These methods automatically run the given task on the common fork join pool, which is Java's default thread pool for parallel processing. But you can also specify a custom executor, which is essentially a way to manage how tasks are run.
I see. And once we have a completable future, what can we do with it that we couldn't do with a regular future?
The real power of CompletableFuture lies in its ability to chain operations. You can use methods like thenApply, thenAccept, or thenRun to specify what should happen after the initial computation completes. This allows you to build a pipeline of asynchronous operations, each depending on the result of the previous one.
That sounds powerful. Can you give us a real-world example of where this might be useful?
Absolutely. Let's say you're building a web service that needs to fetch user data, then use that data to make an API call, and finally process the result. With CompletableFuture, you could chain these operations together. First, you'd fetch the user data. Once that's done, you'd use that data to make the API call. And finally, you'd process the result of that call. If an error occurs at any point, you could handle it gracefully. This creates a clean, readable pipeline of asynchronous operations.
Wow, that's really elegant. But what happens if an error occurs in one of these steps?
Great question. CompletableFuture provides robust error handling mechanisms. We can use the exceptionally method to handle any exceptions that occur in the pipeline. There's also handle for more complex error handling scenarios where you might want to recover and continue the pipeline.
I can see how this would be really useful for managing complex asynchronous workflows. Are there any other advanced features we should know about?
Absolutely. One powerful feature is the ability to combine multiple completable futures. For example, you can use methods like all_of to wait for multiple futures to complete, or any_of to wait for the first one to complete. This is incredibly useful when you need to coordinate multiple asynchronous tasks.
That's fascinating. It reminds me a bit of JavaScript promises. How do completable futures compare to those?
Great observation, Sheila. Completable futures and JavaScript promises are indeed quite similar in concept. Both allow you to work with asynchronous computations and chain operations. However, completable futures are more feature-rich, offering a wider variety of combination and composition methods. Also, being part of Java, they integrate seamlessly with Java's strong typing system and work well with Java streams.
Thanks for that comparison, Victor. Now, as we wrap up, could you share some best practices or common pitfalls to avoid when working with completable futures?
Certainly, one key best practice is to always handle exceptions, either using exceptionally or handle. It's easy to forget about error handling in asynchronous code, but it's crucial for robustness. A common pitfall is accidentally blocking the main thread. Remember, methods like get will block until the future completes. Instead, use non-blocking methods like thenExcept to handle results asynchronously. Lastly, be cautious about shared mutable state. Completable futures make it easy to write concurrent code, but you still need to be mindful of thread safety when accessing shared resources.
Those are great tips, Victor. Now, I think it's time to reveal the answer to our quiz question. The primary advantage of using a completable future over a regular future is
the ability to chain operations and create complex asynchronous workflows. While a regular future represents a single asynchronous computation, a completable future allows you to compose multiple asynchronous operations, handle their results, and manage errors in a much more flexible and powerful way.
Excellent! Well, that wraps up our episode on Completable Future, and with it our chapter on futures and callables. Next time we'll be starting a new chapter on thread basics, where we'll dive into the fundamentals of creating and managing threads in Java. Thank you for listening to Java Internals Crashcasts. If you enjoyed this episode, please subscribe and leave us a rating. Your support helps us continue to demystify Java's internals for developers everywhere. Until next time, keep coding and stay curious.